Hello everyone, welcome back to Math Friend channel. In this video, you are going to learn the second part of tangents and secants, that is constructions of tangents. In construction of tangents, mostly we need radius and the distance from center of the circle to the external point. These two things play a very important role and the question will be framed in three different ways. First question will be how to draw a tangent when radius and the distance from center to external point is given. Second question will be how to draw a tangent when concentric circles are given. That means you are drawing the tangents to interior circle from the point which is on exterior circle. And third one is the inclination of tangents. That is how the tangents are inclined with each other. That angle will be given along with radius. So let's get started. Let us see this question. Draw a circle of radius 3 centimeters from a point 9 centimeters. This is 9 centimeters away from the center. Construct a pair of tangents. First of all, we are going to draw a rough figure for the given information. Here center O, radius is 3 centimeters. Distance from center is 9 centimeters. Now for fair figure, we are going to take compass and scale, measure 3 centimeters with scale, take a point and draw a circle. After drawing the circle, take the center O and from this center, mark 9 centimeters from the center. So we are going to take 9 centimeters from the center. Let the point be P. Half of 9 centimeters is 4.5. We can also take 5 centimeters. I am taking 5.5 centimeters so that it is convenient for us to draw the perpendicular bisector. Now we are going to draw perpendicular bisector to this line OP. So take more than half, that is 5.5 I am taking. One arc up from P and another arc down from P. Then same measurement, same radius, just lift it up. Place it at O and draw the arc. Cut these arcs. After cutting the previous arc, take a scale and join these two. This is the perpendicular bisector. With the help of perpendicular bisector, we will be getting a new point, the point of intersection of this line and the perpendicular bisector. Let us name it as M. Now we are going to adjust the compass in such a way that from M, MO and MP both will be same. Perpendicular bisector means it divides the line into two parts. Therefore, we can observe that both the sides it will be same. It is equal. Both are equal. Therefore, try to keep the compass at M and draw the circle. After drawing this circle, we can see two intersection points here. This new circle is intersecting the previous circle at 2 points. Let us name it as A and this one as B. And join PA. Draw it as a ray and PB. This is how we are going to complete the construction. You can also join this OA, which is the radius of the circle, and here it is point of contact. AP and BP are tangents of the circle. You can go on with verification part also, like applying Pythagoras theorem. Let us move on with the second one. It is concentric circle. Concentric circle in the sense, circles having same center but different radii. Circles having same center but different radii. They have given one circle is of 4 centimeters, another circle is of 6 centimeters. Now inner one will be 4 centimeters, outer circle will be 6 centimeters. Try to draw a rough figure for the given information. This is also same like the previous one, but here instead of distance, they will be giving us concentric circle. We are able to understand that R is equal to 4 centimeters and the distance from center would be 6 centimeters. Let us take compass. Measure 4 centimeters. Try to draw a very neat circle. Draw the circle. This is with 4 centimeters. Now with same center, take 6 centimeters. Measure it correctly, 6 centimeters. Take same point and try to draw another circle. Now these circles are called as concentrics. After drawing the concentric circles, now take any point P on outer circle. Join OP. This OP is of how much length? 6 centimeters. This one is the inner circle's radius, which is 4 centimeters. Now we are going to draw perpendicular bisector to this OP. Now we are going to take more than half. More than half means 6 centimeters is the radius. So half of 6 is 3. We can take 4 or 4.5. I am taking 4.5 so that it doesn't intersect with inner circle. From P I am going to take one arc up, one arc down. Same radius, lift it up, place it at O, intersect the arc and intersect the arc down. Now we are going to join these two arcs, the intersection of two arcs, which is called as perpendicular bisector. This perpendicular bisector divides this OP into two equal parts. Take this intersection point as M. You can observe very clearly that MP will be equal to OM. Now place the compass at M and try to draw a circle. Now we are going to see 2 points of intersection. These 2 points of intersection, you take it as A and this one as B. Be careful when you are taking the intersection of points. This new circle is intersecting with inner circle. So check it carefully with the inner circle, not with the perpendicular or anything. Join PA and PB. These two are the tangents. To highlight, you can use any color pencils so that it looks attractive. PA is one tangent and PB is another tangent. So this is how we are going to draw tangents for concentric circle. If you want to verify, you just take a radius which is perpendicular to this tangent. So it forms 90 degrees here as it is point of contact. If you want to verify this one, you can just take this triangle. In triangle AOP, AOP. Here we can see clearly angle A is equal to 90 degrees because this is point of contact. Now as it is 90 degrees, OP is the hypotenuse. So OP square is equal to OA square plus AP square. OP square is 6 centimeters, so we will take it as 6 square is equal to OA square is 4 centimeters, 4 square plus AP square. Further we can take it as 6 square minus 4 square is equal to AP square. Here we will be getting 36 minus 16 equal to AP square. So it is 20 is equal to AP square. 20 can be taken as it is root 20 is equal to AP, where this can be written as root over 4 into 5. 4 5s are. So 2 root 5 is equal to AP. 2 into 2.23 is AP. That is 4.46. If you want to cross verify, you can just check this AP. Nearly 4.46 here. Exactly verified. Sometimes additionally they will be asking this verification. Verification should be taken with the help of this right triangle. And this is how we can verify the answer. And check the measurement after verifying it. Let us move on with the third question. Now here's the third question. Draw a pair of tangents to a circle with radius 3 centimeters. R is given as 3 centimeters and the tangents are inclined to each other. Inclined to each other means the angle between these two tangents is given as 60 degrees. Now we should just draw a rough figure according to the given information. This is 3 centimeters. This is O. This is O. And this is A. And this is B. You can take this point to be P. This time we can observe one thing. Distance between O and P is not given. So we can go on with trigonometry here to find OP value. So we can take the triangle as 30 degrees, right? I'm just showing the triangle separately. Here it is angle 30 degrees. This is 90. And here 3 centimeters. This is OP. We are going to find this value. So to find this value, we can take this one as theta. Just try to recollect your trigonometry concept. Theta's opposite side is OB, adjacent side is BP, and hypotenuse is OP, which is opposite to the angle 90 degrees. Opposite by hypotenuse we want because we are bothered about hypotenuse. So we can take it as sine theta is equal to opposite by hypotenuse. So sine 30 degrees is equal to opposite is 3 and OP we don't know, so we write it as OP. Sine 30 is 1 by 2, that is equal to 3 by OP. Cross multiply, we will get OP is equal to 6 centimeters. It means that radius is 3 centimeters and distance from center is 6 centimeters. We can draw the circle with radius 3 centimeters and distance from center is 6 centimeters. Draw a circle with 3 centimeters. Take the center as O. From O, the distance is 6 centimeters. So take a distance up to 6 centimeters. Take this point as P. Now we got the distance as 6 centimeters. So it's very easy to proceed further with the construction. Half of 6 is 3. So we can take 3.5 or 4. I am taking 4 for our convenience. It's up to you. You can take 4. So I am drawing one arc up, one arc down from P. Lift it up. Same radius. I am placing on O. One arc up, one arc down. After drawing these arcs, we are going to join these two. This is a perpendicular bisector of OP. After drawing the perpendicular bisector, we can see that perpendicular bisector intersects OP at a point. Take it as M. One thing we can observe right from the first problem, perpendicular bisector is in the middle and it is touching the circle. Suppose if the midpoint is less than circle, then it comes inside. If the midpoint is more than circle, it comes outside. But here the midpoint is same as the radius of the circle. Therefore, it is touching the circle. Now we can check the measurement. MP is equal to M. Place a compass here and try to draw the circle. After drawing the circle, from P, check the point of intersection. This new circle is intersecting with the previous circle at 2 points. This is A and this is B. PA one tangent and PB another tangent. In this way we can complete the construction even if angle of inclination of the tangents have been given. This is third type of construction here. If you further want to go on with the verification, you can join this OA where this is forming a 90 degrees angle and go on with calculation. We can take OP square. OP square is equal to OA square plus AP square. OP square is 6 square is equal to OA square is 3 centimeters. 3 square plus AP square. So 6 square is 36. So if you want to calculate the verification part, you can carry on in this way. This is how the third type of question is being solved and constructed. Further, you take some practice questions. Each of one type you can practice. So I hope today you have learned how to construct tangents to given circles. You need to understand which category the question goes, whether first one, second one, that is concentric circles, or the tangents are inclined to each other by given angle. So these three types, if you are thorough, construction part of tangents and secants is clear. I hope the video was informative. Do share your valuable comments and feedbacks in the comment section. Thanks for watching.